Okay, so yeah, we no Logan, not right now. We added whatever completed the square here for our quadratics, and then we want to add, and then we factored it into a perfect square, and then we added this other side here, so that is 36. Okay, so you'll see that again. So this is what you want to graph. This tells us that our center, we're going to read it right off of that right off of the formula. We read the opposite of what's next to x, so -3, and the opposite of what's with that y, so 2. And then the radius is whatever that 36 square rooted is, and the square root of 36 is 6. So then I'm going to clear my graph, okay, and then I'm going to put a center at -3, 2. Whoa, nope, I didn't want to do that. Okay. So a center at -3, 2, and then a radius 1, 2, 3, 4, 5, 6. And then we submit. Yay!
Looking outside.
No outside right now. Just let me finish, okay? Yes, I love you. Come on, baby.
I hurt my pinky toe.
Oh, pinky toe. Okay, go sit down. Go. One second, baby. 1 second. Okay, sorry about that momentary cutie pants interruption. So we want the standard equation for a circle who's centered at 6, 4, and radius is 5. So you're going to look for an equation that has a 6 and a 4. And remember, it's always opposite. So if it's positive 6 there, that means it's going to look like -6 in the equation. Same deal with 4. And whatever goes after the equal sign, you always take the radius and you square it. So it looks like our correct answer is C. Yay! Okay, number 9. So this one has a center of -9, 8. Oops. And a radius of that. So same deal. When it goes into the equation, it's always the opposite. So we would look for a +9 in the equation and a -8. And then we want to square 3 square root of 5. And when you square that, that's like going 3 radical 5 times 3 radical 5. Not right now, buddy. And that you can easily do in Desmos. You can type it right in like that. Or a calculator. That's what I'm doing right now. 3 square root of 5. Because I'm pretty sure I know the rule, but you know, kids are up, brain is preoccupied. Yeah. What we actually do is we end up multiplying the numbers in front, so it's 9. And then radical 5 times radical 5 is radical 25, which is just 5. And 9 times 5 is 45. So we are looking at +9 minus 8 and a 45. We're looking at A. All right. Number 11. Cool. Okay, sketch the graph. Okay, so we're looking at a circle here. Okay. So same deal. You get to see that completing the square again, which is super awesome. So first thing we're going to do is we're going to move this -31 to the other side, because any plain numbers we just don't want to deal with. And when you move things to the other side in algebra, you always do the opposite of what's there. So we would add it. So now I'm dealing with x squared plus y squared minus 2x plus 4y equals 31. Now I'm going to rearrange it. That's the next step. So all the x's are together. X squared minus 2x. That's going to go in one, and then the y's are going to be together. Now we're going to complete the square. So we take half of that b term and square it and add it to here and then to the other side. So half of negative 2 actually is 1, negative 1, and negative 1 squared is 1. So we're going to add a 1. Half of 4 is 2, and 2 squared is 4. My son's a ninja, so we're going to add 4. So on this side, we have to add a 1 and a 4. Ninja. Yes, buddy. So now I'm left with...
Can you see my ninja chop?
Not right now, dude. He's got an epic ninja chop, but Mom is busy. 36 again. Yay. Okay, and remember, to get that number that we have here, the 1 and the 4, all we did is we took half of negative 2, which was negative 1, and then we squared it, which was 1. That's how you complete the square, and that's what you add there. You do it again here, and then add them both to the other side. Now we factor, and to factor it, you just put whatever you got when you divided by 2. So when we divided by 2, we got negative 1. And when we divided by 2 over here, we got 2. Look at that. That's just beautiful. So this tells me, if we're reading the opposite, this tells me that we have a circle that is centered at, we read the opposite. No, I'm not ready. Not right now. No, not right now. Go sit down.
I really need to.
So we have a circle that's centered at 1, negative 2. That's the center. And the radius is going to be the square root of that 36, which is 6. So, sorry for the interruptions, guys. Can't help it. That's my children. So 1, negative 2, and then 6. 1, 2, 3, 4, 5, 6. Yay! Okay. They want to know, the graph is a circle with a radius of 6, and the center, what was the center? Let's hit undo. 1, negative 2, that was the center. 1, negative 2. Yay! Last one, friends. Last one. Oh, I love this one.
Mom, I can't take this part anymore.
The parabola, ellipse, and circle and hyperbola, they are all called conic sections. That's what they are. Conic sections. Yay! And we're done. So please hand this in and get ready for video number 2. Thank you, friends.